Okay, so I'm working on the final review, the very first one that I gave you, just showing you this last page with all the factoring. Okay, so let's take a look at this one. I see there are 3 terms. First of all, always take out the common factor. Are there any common factors? No. Okay, 3 terms. Is it quadratic? No, this is a 4, not a 2. So is it in quadratic form? Well, this is 4. The middle one has to be half of that, and no x over here. Great. Quadratic form. We factor it very similarly to a quadratic equation. This number right here tells me how many answers I should have in the end. I should have 4 answers in the end. All right, so quadratic form. Let's take a look. Underneath 2x to the 4th, keeps losing focus. Okay, 2x squared times x squared, and 20. We could do 5 and 4. Yes, that actually works. 5 times 4 is 20. 2x squared times x squared is 2x to the 4th. Test it out. 8x squared, 5x squared. Can I get a 3x squared from that? Yes, I can, as long as the 8 is positive and the 5 is negative. So the 4 needs to be positive and the 5 needs to be negative. That shows me what goes into my set of binomial parentheses. 2x squared minus 5, and then x squared plus 4. Now, the next thing I need to test, if there are 2 terms, which each of these binomials have, 2 terms, are there difference of squares? Well, here I see a perfect square, but that's not a difference. Here's a difference, but these are not perfect squares. Is it sum or difference of cubes? No, it's squared terms, so I can use the zero product property and square root equations to solve. 2x squared minus 5 equals 0. X squared plus 4 equals 0. I should get 2 answers here and 2 answers there to get a total of 4 answers. 2x squared equals 5. X squared equals 5 over 2. Square root both sides. X equals square root of 5 over square root 2. Okay, so right here, if you have a square root over a fraction, you can separate it to make it a square root of the numerator over square root whatever the denominator was. These are the same. Square root 5 over 2 is the same as square root 5 over square root 2. And this allows me to rationalize the denominator by timesing both the top and the bottom by root 2 over root 2, a special form of the number 1, and I have root 10 over 2. And I love to forget this, so please, please, please do not forget it on your test. Plus or minus, because every time you square root in the middle of an equation, you need to show that there's a positive answer and there's a negative answer there. All right, subtract 4 on both sides. X squared equals negative 4. I'm going to square root both sides. X equals plus or minus. This time I'm not going to forget it. And since this is a negative 4, usually the square root of regular 4 is 2. But having it be negative 4 would be 2i, because the square root of negative 1 is I. Plus 2i, so positive 2i and negative 2i, those are 2 answers. Positive root 10 over 2 and negative root 10 over 2, those are 2 answers. I have my total 4. All right, 41. Always take out the common factor. What do you see? I see an x that's in common, no numbers in common. When you have a negative in front, always factor it out. You just don't want to deal with it when it just messes up a lot of things and makes our lives more complicated. So just factor out that negative. So negative x is what I'm going to factor out. Negative x times 8x cubed would give me 8x to the 4th, negative 8x to the 4th, and then minus 125. All right, now I have, okay, that's done, great. Now I have a binomial. It is difference of cubes, okay? 8 is a perfect cube. X cubed is a perfect cube. 125 is a perfect cube. And you can do sum or difference with cubes. So drop this down, but the perfect cubes are going to go into here. The formula goes as follows. It's not very intuitive, so you're going to have to be you're going to have to put it on your note card or memorize it. At some point in time, you should have it memorized. Cubed root of 8x cubed is 2x. Cubed root of 125 is 5. Drop the sign. The first term is the first term squared. The last term is the last term squared. If the minus is out here, then we're going to have 2 pluses in here. Why? Because there's always 1 minus, 2 pluses. And the middle term is this times this. Don't worry about those signs, just those numbers. All right. Now we have completely factored. Every time you factor difference or sum of cubes, you have to do quadratic formula. There's no other way. There's no way of factoring this further. Otherwise, they would have put that in the actual formula for it. So we use the zero product property for these two. Negative x equals 0, which just means that x equals 0. 2x minus 5 equals 0, which means that x is equal to 5 over 2. And then quadratic formula. X is equal to the opposite of b plus or minus square root. B squared minus 4 times a times c all over 2 times a. A is in front of the x squared term, b is in front of the x, and c is the constant on its own. Continue. Negative 10 plus or minus square root. I'm going to find the determinant, which is everything that's under here, using a calculator. I would avoid doing the square root because we want the exact answers. So just put everything under the square root, but not the square root symbol. And if you plug it in correctly with the parentheses and everything, you'll get exactly what you're supposed to get. The calculator will do all the order of operations for you. Negative 300. Yeah, so if we had put the square root in the calculator, it would have given us an error, and then we wouldn't be able to keep going with the problem. I mean, that's why imaginary numbers exist, so that we can solve problems like this. All right, so square root of negative 300. I'm going to break it down. That can be the biggest perfect square that goes into 300 is 100. Definitely, there's going to be a square root negative 1, which is going to be I, the imaginary number. And then 100 times negative 1 is negative 100 times 3 gets me back to the positive 100. So square root of negative 300 can be written as the product of these three, which will just help us break down the square. 10I root 3. All three of these numbers are divisible by 2. So this is now negative 5 plus or minus 5I root 3 over 4. That's two answers. You have negative 5 plus 5I root 3 over 4 and negative 5 minus 5I root 3 over 4. Then we have 5 over 2 and 0. And how many answers did they say we needed? 4. Moving on. Take out the common factor. Always, always, always take out that common factor. So the common factor here is just x. And we're left with something that is quadratic form, just like the one above. So keep going. Factors of 56, we could do 7 and 8, 8 and 7. Yeah, it should be 8 and 7. And we'll test it. I already did in my head, but we want to make sure that we can see that it's correct even with all the signs, right? Because the numbers could be right, but then we have to check those signs. Positive 35 minus 8. Yeah, that does give me positive 27. So negative 8 and positive 35. Positive times a negative is a negative, so that does indeed work as well. This trinomial factors to be 5x squared minus 8 x squared plus 7 equals 0, and of course drop down that x. All right, zero product property, x equals 0. 5x squared minus 8 equals 0. So x squared is equal to 8 over 5. I'm skipping some steps. I think most of you can do this. It's, wow, no longer squared, that's for sure. Square root 8 over square root 5. Rationalize the denominator, square root 5 over square root 5. Square root 40 over 5. And there is a perfect square that goes into square root 40. I'm going to go to the next level. So 4, so square root 4 times square root 10 over 5. And that gives me 2 root 10 over 5. Plus or minus? All right. Very forgetful. Plus or minus. Do not forget that. Although, since your test is multiple choice, they're going to have those options for you already. X squared plus 7 is equal to 0. X squared equals negative 7. X is equal to, now the negative can be taken out and becomes I. Don't forget your plus or minus. I. And then root 7 cannot be simplified further. Two answers, one answer gives me 5. And finally, common factor? No, but there are 4 terms, so we're going to do grouping. Don't look at the second part, just look at the first. Any common factors? Now look at the second part and not the first. Take out that negative. Anytime you have a negative in front, it's just easier to take it out. Plus you have to for grouping. No common factors, so we're just going to take out that negative. Plus 5 equals 0. Okay, so the common factor here is the repeated binomial. So when we take it out once, we write it one time, and we divide it from both of these terms. Be very careful, because when you divide this whole term by 3x squared plus 5, you're left with x to the 4th. And it would be tempting to just leave that because you're like, oh, well, there's nothing else there. But if you take this term, which there's an imaginary negative 1, when we took out a negative, we're really just taking it out a negative 1, but I'm going to write the 1 because we don't need to. So when we take this whole term and divide that by the binomial 3x squared plus 5, then we have negative 1. We can't use zero product property yet because you still have something to the power of 4. And we really have to break it down until it's like squared. Otherwise, we're going to lose some of our roots. We're not going to get all 6 of them. So this one has been broken down enough, but this one, not quite. So this is a binomial. Is a difference of squares or difference of cubes? Well, difference of squares, because x squared times x squared would give me x to the 4th, and 1 times 1 gives me 1. X squared plus 1, x squared minus 1. Now, I'll have 2 answers here, 2 answers there, 2 answers there. Great. Use zero product property to solve. Okay, x squared equals negative 5 over 3. Plus or minus negative 5 with a root over root 3. I'm going to do 2 steps in one. I'm going to take out that I at the same time. I mean, I guess we could take it out later. So plus or minus I root 15 over 3. All right. Does that make sense? This negative became I outside of the root, but 5 times 3 is 15 under the root. That's 2 answers right there, and I think it's going to be easier here. We have x squared equals -1, so x is equal to plus or minus I. That's the definition of the imaginary number. X squared is equal to +1, so x must be equal to plus or minus 1.